Today I'll be deriving the derivative of ln x, and as a preliminary you need to know what e equals. E equals some lim as h approaches 0, 1 plus h over 1 over h, and h is just a random arbitrary variable, and you should know that. Okay, so let's start with the standard derivative formula. So ln x plus h, tiny change in h, minus ln x over h. Alright? And this just equals 1 to the h of ln by the log rule, x plus h over x. Because when you subtract two logarithms, you can divide them. Like so. And then we get to here, equal. And then by the exponent rule for logs, we get this, x plus h over x to 1 over h. Okay? Then we further get this. X over x is 1 plus h over x over 1 over h. And something you should notice here is this actually looks really similar to this. So how can we get from this to this? Well, the key is to multiply. Let's say x is equal to some, let me think. Oh no, let's say h over x is equal to some z, and as h approaches 0, lim z goes to 0 along with h. So yeah. So let's take this first, and we can do this. X times 1 over x equals ln 1 plus, we're not breaking any rules here, because x times 1 over x is just 1. So, and there's already a 1 in front of everything. So by exponent rule, we can bring this x over here. So 1 over x ln 1 plus h over x and x over h. And like we said, h over x, we can set it to equal to some z. So 1 over x ln 1 plus z, 1 over z, because x over h is just z flipped. And look, as h approaches 0, z approaches 0. So what's lim z approaches 0 of 1 over x ln 1 plus z, 1 over z? Well, look, this is just e, but with different variables, so you get the same thing. So it's just 1 over x ln e equals 1 over x. And that's the derivative of ln x. Thank you.